video we're going to look at calculating the number of protons, neutrons and electrons for atoms and their ions using the periodic table. To start with, we're going to look at what atoms are made of. So atoms are made of three types of particle. They are protons, neutrons and electrons. You should also know that protons and neutrons are found in the nucleus and are sometimes referred to as nucleons. Electrons are found in shells or energy levels surrounding the nucleus. The next thing you should be able to do is to work out the number of protons, neutrons and electrons for an atom from the periodic table. So if we take carbon as our example, you'll find carbon on the periodic table has two numbers next to it. These are the atomic number, which has the symbol Z, and the atomic mass number. If we look at calculating the number of protons, this is equal to the atomic number. So if we looked at carbon, we could say that carbon has 6 protons. The number of neutrons can be calculated using the atomic mass number, take away the atomic number. So if we looked back at carbon, we would say 12 take away 6 gives us 6 neutrons. And finally, if we look at the number of electrons, now I'm going to use the calculation atomic number, take away the charge. It may be that in previous studies you've looked at this and said the number of electrons is equal to the number of protons, and you would be quite correct if you were talking about a neutral atom. So if we were looking at carbon as a neutral atom, then the number of electrons would indeed be 6. However, in this video we're also going to look at calculating the number of electrons in ions, and therefore it's quite useful to use this calculation. One more thing I'd just like to make clear before we proceed through this video is that the number of protons never changes. Okay? If we look at carbon, in the nucleus of a carbon atom there are 6 protons. If that number changed, if for example there were 7 protons, then that would no longer be an atom of carbon. In this first example, we're going to stay with lithium, just to reinforce what we said in the introduction of this video. So if we look at lithium, this is how it would appear on your periodic table, and you can see that it's got two numbers. We've got the mass number, or the atomic mass number, and we've got the atomic number. What I'd like you to do is to work out the number of protons, neutrons and electrons. Pause the video for a second now. So if I'm going to look at the number of protons, I will say that the number of protons is equal to the atomic number. And if an examiner asks you this type of question, all they are testing is your ability to use the periodic table. So the atomic number is 3. There are 3 protons. We said in the previous section that the number of neutrons is equal to the mass number. Take away the atomic number, which gives us 7. Take away 3, 4 neutrons. The number of electrons in this case is 3. Now there are 2 ways that you might have arrived at that number. So you may have said, this is lithium as it appears on the periodic table, therefore it's a neutral element, therefore the number of electrons is equal to the number of protons. Okay, so we could have said protons equals electrons. Okay, now I said in this video we were going to use the calculation too, because when you come to using or calculating electrons for ions, the calculation is quite useful. So we said that that was the atomic number take the charge. Okay, so in this case the atomic number is 3. Lithium has no charge because we're talking about a neutral atom. So that gives us 3 electrons. Now that might seem quite a long-winded way of arriving at the same number, but you'll see why I'm introducing that calculation in a moment. Okay, so carrying on. I've just written quite neatly here, protons, neutrons and electrons in a neutral atom of lithium. So if we were to draw a diagram of what that might look like, in the nucleus we would have 3 protons and 4 neutrons. So 1, 2, 3, and 1, 2, 3, 4 neutrons. Surrounding the nucleus we would have 3 electrons existing in the first and second shells. Now many of you will know from previous studies that when lithium reacts it likes to lose that outer electron here. So this outer electron will be lost, giving it a complete outer shell. So we just get rid of that. That outer shell can disappear. And you probably also know from previous studies that what we do then is give it square brackets and a charge. So now we have Li+. Okay, so moving on, we're going to look at protons, neutrons and electrons in Li+. Now we said before that the number of protons never changes, so the atomic number will stay the same. We're not talking about an isotope, so we're going to keep that 7 there for now. And we're going to do protons, neutrons and electrons for Li+. Pause the video whilst you have a quick go at it. So the number of protons is equal to the atomic number, so it's still 3. The number of neutrons is the mass number, take the atomic number, so we've still got 7 take 3, gives us 4 neutrons, but the number of electrons is now different, so we're going to do atomic number take the charge. So we've got atomic number is 3, take away the charge is 1 plus, 3 take 1 gives us 2 electrons. The most common way for this question to appear on an exam paper is in a table, something like this. The question will say something like, complete the table with the number of protons, neutrons and electrons for lithium and its ion Li+. So as I previously said, what this is testing is whether you can use your periodic table to correctly identify lithium and calculate from that the number of protons, neutrons and electrons. So what you would do if you were in an exam is go to your periodic table and find lithium, which as we know by now looks like this, and then we'd do our calculation. So for lithium, let's put those numbers in. Okay, so for lithium, atomic number 3, neutrons, we're going to do 7 take 3, gives us 4, and electrons, so it's an uncharged atom of lithium, so whether you're just going to say it's neutral, therefore it's the same as protons, or whether you do atomic number take the charge, giving us 3 electrons, either's fine. When we look at Li+, we've still got 3 protons because as we said, those protons never change. When we look at the neutrons, it's still 7 take 3, so we've still got 4 neutrons. Now the electrons have changed, so we've got the atomic number take away the charge, which is 1 plus, giving us 2 electrons. So in an exam, let's just take those calculations away. If your table looked like that, then you would receive full marks for this question. going to move on through some more examples, so this is your chance to practice, pause the video and then check with me whether you've got your answer correct. So the next one is about oxygen. Again, you could go and locate oxygen on your periodic table. It would look like this, and what I want you to do is to work out the number of protons, neutrons and electrons in oxygen. Pause the video now whilst you do that. So as we previously said, protons is equal to the atomic number, which is 8. Neutrons is equal to the mass number. Take away the atomic number. So we've got 16 take 8 gives us 8 neutrons. And the number of electrons is 8. So whether you said this is a neutral atom, therefore it's the same as the number of protons, or whether you did atomic number, take the charge, which in this case would be 8 minus 0, which gives us 8. So your answer should be 8, 8, 8. Carrying on, sticking with oxygen. Oxygen is in group 6, which means that it likes to make 2 minus ions, like so. What I want you to do now is, again, to work out protons, neutrons and electrons in O2 minus. Pause the video whilst you do that now. So, protons, again, never changes, stays as 8. Neutrons, because we're not dealing with isotopes at this point, is still 8. And electrons, so this time we've got the atomic number, take the charge, so we've got 8 minus 2, which gives us 10. So your answer for the second part of this question should be 8, 8, 10. Once again, looking at the way that this would appear in an exam question, so it would appear as a table on an F321 exam, and you would have, similar to what I said last time, which is complete the table showing the number of protons, neutrons and electrons for oxygen and its oxide ion, something like that. And you would need to fill in those numbers. So for oxygen on its own, we've just worked out it was 8, 8, 8. And for O2 minus, the oxide ion, it was 8, 8, 10. This example, you are going to need to find aluminium on your periodic table and complete the table as I've shown on screen. Pause the video whilst you do that now. So what you should have done is gone to your periodic table and found that aluminium is element number 13 and it has a mass number of 27. Therefore, the number of protons in both aluminium and its ion is 13. Neutrons, we've got 27, take 13 gives us 14. Okay, again, we're not dealing with an isotope here, this is an ion, not an isotope, so it stays as 14. And the number of electrons, so in the neutral atom, we've got electrons is equal to the number of protons, which is 13. In the charged ion, we've got atomic number, which is 13. Take away the charge, which is 3 plus, gives us 10 electrons. And that's what your table should look like. Again, we're sticking with fairly snappy examples here, so another table as it would appear on your exam paper, maybe 2 marks for this. Complete the table for the number of protons, neutrons and electrons. Pause the video whilst you complete the table. So if you've gone to your periodic table, you'll find that nitrogen looks like this. So again, protons is equal to the atomic number, so that is 7 in both nitrogen and its ion. The number of neutrons, we've got 14, take away 7, 7 neutrons in both. and electrons. So in the neutral atom we've got 14 take away 0, apologies, 7 take away 0, which gives us 7 electrons, and in the charged ion we've got 7 take away -3, which gives us 10 electrons. Once again, a table for you to practice with. In this table we've got calcium, so pause the video whilst you locate calcium and complete the table. So what you should have found using your periodic table is that calcium has a mass number and an atomic number as shown there. Now what you might need to bear in mind here is that we have to deal with whole numbers. Okay, so if you'd gone to your periodic table and calcium is 40.1, you cannot have 0.1 of a neutron or a proton, so therefore you need to deal in whole numbers. So that's just something to bear in mind. So if we look at the atomic number, we can see that the number of protons is 20, the number of neutrons is 40, take away 20, so that's 20 again. Number of electrons, so neutral atom equal to the number of protons, or you can do it as 20 take away 0, so that's 20 electrons. And in the ion we've got 20 take away 2 gives us 18 electrons. In this final example we are looking at an element that has more than one ion, so it is a transition element with variable oxidation states. So again, same question, just an extra row to deal with. I'm going to ask you to pause the video whilst you locate ion and complete the table. So what you should have found is that iron is element number 26 and it has a mass number of 56. Remember, we have to deal in whole numbers, so we will have rounded that top number. And from that we can see that the atomic number is 26, so each of these atoms would have 26 protons. Neutrons, we're doing 56, take 26, which is 30, so 30 neutrons in the atom, 30 neutrons in Fe2+, and 30 neutrons in Fe3+. Looking at the electrons, so we're doing atomic number, take the charge, which is 0 for the neutral atom, so 26 electrons. For Fe2+, we're doing atomic number, take the charge, which is 2, 24 electrons. And then in Fe3+, 26 take away 3, 23 electrons. And that's what your table should look like if you have answered this question correctly.